By the end of this lesson, you should be able to define elastic potential energy and state that EP equals half kx squared. Describe related applications of elastic potential energy. Solve related problems involving elastic potential energy. Stickman and the Earth are objects in an interactive system. Work was done to lift Stickman. When Stickman is lifted, his position in the system changes. Stickman now has potential energy. What happens to Stickman when he is released? What kind of potential energy does he have? Stickman falls towards Earth, back to his original position. He has gravitational potential energy. Look at the magnets. There is a magnetic force between them. They form an interacting system. When we pull them apart, we are doing work against the magnetic force. Their positions in the system change. The magnets gain potential energy. What happens when the magnets are released? What kind of potential energy do the magnets have? When the magnets are released, they move back together. They have magnetic potential energy because of the magnetic field. Forces govern objects in an interacting system. When work is done to move objects against these forces, they gain potential energy. Potential energy is caused by the position of the objects. Let's consider the molecules in a spring as an interacting system. They have intermolecular forces. Can you explain in terms of work and energy what happens to the molecules when the spring is stretched? When the spring is stretched, work is done to move the molecules apart against intermolecular forces. Their positions within the spring have changed, and they gain potential energy. Collectively, the energy of the molecules becomes the elastic potential energy, sometimes known as strain energy of the spring. Oh look, it's Stickman again. As always, he is using a spring to get about. If you look closely, the spring is being compressed. All that hopping must take a lot of energy. Can you explain what energy he uses to move about and where it comes from? When Stickman gets on, the spring is compressed. Work is done to squash the molecules in the spring together against their intermolecular forces. Their positions within the spring changes, and the spring gains potential energy. The spring's potential energy is then converted into kinetic energy of Stickman's movement. Our bird hospital is as busy as ever. The weight of the birds in the nest acts as the external force that does the work to stretch the spring. This will cause the spring to store elastic potential energy. Make a sketch of an appropriate force extension graph for the spring. A stretched spring has stored elastic potential energy. This energy is also known as strain energy. This means that the spring is able to do work on another object by exerting a force over some distance as the spring resumes its original length. We already know that work is the product of force and distance. However, this rule is not applicable in a spring because the force is not constant. The force exerted by the spring becomes less as the extension decreases. Conversely, the force on the spring has to be bigger for the extension to increase. Study the graph closely. Can you think of how work done on the spring can be determined from the graph? The area under the graph is a product of force and extension. This means the area under the graph is the work done on the spring and also the spring's elastic potential energy. By substituting, we see that the spring's elastic potential energy is half kx squared, or area under Fx graph. Pole vaulting is among the earliest sporting events to be contested in modern-day Olympics. It requires a lot of skill as well as athletic ability. There are several energy changes that take place in pole vaulting. Observe the video and name them. The athlete has kinetic energy as he runs in. This kinetic energy is used to bend the pole and carry the athlete forwards over the bar. As the pole bends, energy is stored as elastic potential energy. The athlete uses this stored energy to increase his potential energy to propel them over the bar. When the pole has been released and the bar cleared, the gravitational potential energy of the athlete is transformed into kinetic energy as he falls towards the mat. The men's pole vault world record, which is almost as high as a single-story house. The women's record is about 5 meters. Look at the video again and try to come up with a reason for the difference. Also, if you look at the event closely, you will notice that as the athlete plants the pole in the stop, he bends the pole with his other hand. Added energy is stored in the pole this way. We know that male athletes have more muscle mass and can therefore physically bend the pole more. This transfers more energy into the pole.
In this activity, your mission is to help Stickman rescue the princess. Rescue Manual. The height of the tower can change at any time. You have to work fast. You only get 2 tries to get it right. What you need to do is A. Assume gravitational acceleration is 10 meters per second squared as Stickman's mass is 1 kilogram. B. Calculate Stickman's end gravitational potential energy when he is high enough to reach the princess. C. Calculate the distance the spring needs to be compressed in order to achieve point B. Assume the spring has a spring constant of 50 newtons per meter. D. Load the board with the correct number of rocks to compress the spring. E. Press Launch button. Click on the Add Load button so the rocks are added on to the springboard one by one. Read the instructions to help you decide what to do.